Hello guys, this is Rishikesh from Coding Geeks, and today we'll be doing insertion sort. Insertion sort is a very basic kind of a sorting algorithm which has a minimal time complexity of O of n and maximum of O of n square. It is actually a not preferred kind of a sorting method, but we are still gonna learn it because it's helpful to understand algorithms of various sorting methods. So here we go. So I'm gonna directly start with it. The thing is that we are starting right away with the insertion sort's main crux, and that is it's essentially like sorting playing cards. Like imagine this, like consider this. This is the whole playing card set. 3, 4, 5, 2, 6, and 1 is your playing card set, and you want to arrange it ascending in an ascending order. What you will do is that whenever you encounter any kind of misplaced number, so like consider this, 1 is misplaced and it should be in the first position. So what you'll do, you will just drag the 1 and you will just drag it and put it here, right? You'll put it here and that's it, right? You will see that there's a 2 and you will just drag it and put it in its appropriate place, right? So that's essentially what you will be doing, right? So insertion sort works in a similar way, not exactly like this, but it definitely works in a similar way. So what's going to happen is that I'm going to start with the explanation of how it exactly goes about. So I first initialize a few counters. That is, I put here I, okay, I. Then there is a J counter that I won't be introducing right away, but let's just say that there exists a J counter. Okay, and this is a C counter. I think I can keep it as a C counter, namely. So what I'm gonna do is I'm gonna check, let it be here. So what I'm gonna do is I'm gonna check if mm, I is this I and J may comparison number, and if J, the number at J is greater than the number at I, then they will swap. This is basically what the thing is. Okay, so we start off with this. When, but the thing is that no, they aren't exactly the same, right? So what you do is instead you iterate forward until you meet such a case wherein you have to find that the earlier number is less than the current number. I mean greater than the current number. We don't encounter such a case until a very long time, and when we encounter 2, we encounter such case. Okay, so what happens is that you encounter this case and you realize that 6 is actually greater than 2, and what is 2 doing here? So you just swap it. What you do here is that you mark C equal to I, matlab the point of position, that is this is 0, 1, 2, 3, 4, and 5. So you keep C equal to 5, and this is how you do it. You don't decrease I's value when you are going backwards. By going backwards, I will show you what I mean by. So you swap 2, okay, wait. You swap 2 and 6, and now what you do is you go back by 1 for J, and you also go back by 1 for C. So what you are going to do is essentially you are going to decrement G and C parallelly, and just going to keep checking if they are equal. I mean, if they are meeting the condition, and the condition is that the earlier element should be greater than the current element. The current element that I mean is C, the number at C. Okay. If the condition is met, then there will be swapping, and this will go on and go on. So it happened, we will decrement it again. It's going to happen again, as we can see it clearly. Now we are going to decrement both of these again, and in the end they just are going to get swapped, and this is it. When you encounter that J is greater than or equal to 0, it will just terminate the loop. That's what I have kept the condition as. Now what is going to happen is that after the loop is terminated, it will the I will start iterating again, and the values will be again J here, then C here, right? So you encounter the same thing here. So what it's gonna do is the same thing repeated and decrease this by 1, and this is gonna happen until 1 comes up till here. So I'm not gonna process whole of it, but I think you get the general idea what's gonna happen, right? So this is gonna this is what it's gonna look like after your array is sorted. So this is for the logic of insertion sort. Now we will be executing and implementing the insertion sorts logic into C++. So let's get started with it. I'm declaring int so that I could take in the length of the array that is gonna be inputted. So this is that is gonna be input. So this is the n in this case, and this is gonna be the array. Okay, so get arr, and I by doing this, by performing this, I'm essentially taking in the array like this is which is provided to us. I have defined a macro for that up here on the line number 4. I also defined several other macros. Please do check them out. I will just wait. I'll just extend it a bit. Yeah. So this is it. So these are the macros, and please make sure to check them so that you get the idea what those macros are doing. I'm gonna simply just initialize these and let's get started with it. So for I equal to 1, I less than n, and I plus plus, I'm gonna start the loop. For I'm just so that what if we encounter the case wherein the condition is met. So for that sake, I'm just gonna put c equal to I, so that we don't have to again start all over again and just initialize c and just put I value in it again. So I'll just put it right away right here. Now uh, j will be equal to I minus 1, since we'll be comparing the element right behind it. Okay, so that's the initial position. I could even write C. That's totally fine, but I think writing I will make it much more clear that we are just starting from the element right behind I. That's what my whole and full reason is for this. I could have simply written C, but it's okay. So now what I'm going to do here is that I'm going to swap these two things. That is a okay. Wait, I'll have to first establish the condition if it's met or not. So if ARR of J is greater than ARR of C, then what I'm going to do is swap these two values, ARR of J comma ARR of C, and that's it for the swapping. Else, wait, I'll break. Yeah, and after this, I'm also gonna decrement C. Okay, so that seems okay, right? So by doing this, what I'm doing is the thing that I showed you here earlier, that J and C are swapped if this particular condition, that the earlier value is greater than the current value. If this condition is met, then we will be swapping. So essentially, that's what I'm performing here. C minus minus I have written here because I want to decrement the value of C by 1, and in this, because of this loop, the value of J is gonna be anyway be decremented. And I have written here else break because if once you encounter the condition wherein ARR of J equal to or less than C, then it means that you have finally come to the position wherein you can stay. Like consider this: the array is like 4, 2, 3, and 1. So I want to swap this two, and when I realize that 2 and 4 are, if the condition is met, like I realize that this condition is met, so what I'm going to do is I'm going to swap. So this happens, and then I realized that this one is particularly not in its perfect place. So I will also just put it right here. And when this 3 is gonna come, its chance is gonna come. So what it's gonna realize that 4 is greater than me, so it should be behind me. So you just take 3 and swap. And when you realize that 2 and 3, between 2 and 3, 2 is less than 3, it will else break. This statement will be activated. That's what's gonna happen, and it will be sorted finally. Okay. So that's what's gonna happen. So let's actually, after sorting this, just put out the array so that we could see our results. I think it's time for compiling it. Mm, okay, so I'm just gonna put this exact thing here, and yes, it works a-okay. So that's it for the explanation of insertion sort. Please like, share, and subscribe. If you have any doubts, please post it up here. I'll be glad to answer those. Also, check our Telegram and Instagram so that you are updated, you are in touch with us, and for more, please follow us. Thank you.